starting. Okay, now get a blue. Are there blue M&Ms?
Yeah.
Grab a blue M&M. Okay. And we're going to put the blue M&M on where we are going. So notice we're going to the unit of a mole. Oops, that should be blue. Okay. But it's moles of something different. So it's this moles over here.
Oh, that makes sense.
Because it's starting with oxygen. So this mole right here would be moles of oxygen. But it's moles of something different. Okay. Lights are green. There'll be time to talk later when you practice. But right now I just need to have everyone listening. So after you identify red is where I'm starting, blue is where I'm going, this tells us that this setup is going to take 1, 2 steps. There's no airplanes here. You have to follow the roads. We have to go from liters to moles, and then we can go moles to moles. Yep, so every arrow is like another step. Okay, just follow and write it down with me. Okay, so I'm going to start with what's given. So I'm using markers once again to match as we change. So I'm going to put 2.0 liter of O2. So that's my given. That's where I'm starting. Okay, here's step number 1.
Do we need a lot of liters for this?
2.0 liters.
Like, should I write this big or should I write this small?
You'll be fine. Just put it off to the left because it's just going to be long. That makes sense?
Yeah.
Okay. Whatever unit I'm leaving goes on the bottom, as always, right? So I'm going to put liter of O2 on the bottom of my fraction. The unit that I'm going to is always the unit that goes on top. So I'm going to put mole of O2 on the top. So this fraction represents that first step. I'm going from liters of oxygen to moles of oxygen.
Oh, so this is like a literal step by step.
Yep.
Wait, so you can't just skip from, you can't just do liters, then go straight to like, just put 22 at the bottom, and just one mole at the top.
That's what we will plug in, yes.
But why can't you only do it once? Like, why can't you put that in right now instead of?
So what I mean by a second step is we're going to add a second parenthesis. That's the second step. So the whole first parenthesis is the first step. Okay, now notice the color. We're going to leave moles of O2 and we're traveling to moles of KClO3.
I thought she was going to start spelling someone's name.
Okay, so step 1, step 2. Okay, once again, I like to build the road before I put in any numbers. Right, so I finish it all the way of like cancel, cancel. The thing up here should be the thing I circled because that's what I'm trying to find. Now we can plug in our ratio. So like Kinsey pointed out, liter to mole is the 22.4. So there's 22.4 liters in 1 mole. The mole to mole relationship, we look at the balanced equation. So there's 3 O2s for every 2 of those. And now we're going to put in our calculator. What numbers, Aiden? Look at your map. When you go from mole to mole, where do you look? What's the arrow say between mole to mole? Good. So 3, 2. KClO3, KClO3, O2. Does that help? Here's how I would choose to type it in, everybody. Once again, you could type them in as fractions. I choose just to type it in step by step, where I just divide by that, and then I'm going to times by 2, divide by 3, is how I would choose to type it in. Questions on that? Did someone type it in yet?
Yeah, I got it.
What'd you get, Jack?
0.05.
5?
No, 0.06.
It's
Round it up.
Actually.
And we'd label it as mole of KClO3. Okay, questions before we do another one together? Okay, you may eat those 2 M&Ms.
I got it. He did.
Okay, let's do this one. Grab another red and blue M&M. Stick with my same color. Okay, I'm going to walk through one more, so please zip your lips again. If you feel like you know what you're doing, then you can go ahead and try it on your own, but no talking, because I want to walk through those that want to see one more with me, okay? And then I'll give you a chance to practice. Okay, the question says, how many grams of copper? So that's my goal. So I'm going to grams of unknown. So right up here's my unknown. Are required to react with 0.1 grams of silver. So I'm going from grams of one thing to grams of something else. So how many steps? Show me on your fingers how many steps is this going to take me?
3.
Good. If you thought or said 3, have a smiley face. You're good, Caitlin. Okay, so I'm going to start with the given. 0.1 gram of AgNO3. Okay, so step number 1 is grams to moles of the same substance. Okay, the unit you're leaving goes on the bottom, the unit you're going to goes on top. So I'm going to moles of AgNO3, and I'm leaving grams of AgNO3. Once again, I'm going to just keep building my 3 steps, and then I'll come back for the numbers.
So then you're leaving moles of AgNO3.
Good. So I'm leaving moles of AgNO3, and I'm traveling to
Moles of silver nitrate.
moles of silver nitrate. I mean moles of copper.
Which is Cu.
We were leaving silver nitrate. Yep, which is just Cu. And then my final step is to leave moles of copper and go to grams of copper.
That's just, I'm gonna get lost.
Wait, there's 4? Or no, there's 3.
3. So each parentheses is a step.
Because I ran out of space.
No, that's the end. Me too.
Okay.
Okay, questions on the steps. I promise, I know it's a lot of writing and a lot of units, but if you write it out, it will prevent you from getting it wrong because you'll see and catch your own mistakes. Once again, because it just follows each step one by one. Okay? So my first pathway here in orange is gram to mole, which uses molar mass. So we need to find the molar mass of AgNO3 to plug in on the top or the bottom of that fraction. The bottom, because that's where the gram unit is. So let's add up AgNO3. I think it's like 140. No, that's.
Selfies are over here looking it up. We're all doing like the actual. I don't have enough room to do it. That's the issue.
169.87. Oh, sorry. I was trying to be helpful. And then what number would go on top? Yep, because that's how many one of them weighs. Yeah, go ahead.
Don't put the red. On the, is this on the quiz? I'm assuming. Like, will we have the map?
Like that?
Yeah.
Yes.
Or no. Okay.
Yeah.
And then what happens? Never mind. I guess if you get lost with your units, then you're just lost.
So that's why you just take it step by step.
I'm just confused why we haven't been doing these step by step now. Like they weren't required to have like 2 or 3. It was just like
Because before it was just like the question would be like, how many grams are in moles of silver nitrate? So it was just one step. Or how many moles are in moles? But the way the question is asking is it's linking units together.
so it's going like too far apart.
Does that make, yeah, it's too far apart to just do it in a single step. So, yes, Megan?
So when I did it, like I got like the same number, but I got like instead of 86.
That's fine. It was probably just the periodic table you looked at, but that's fine. So, okay, eyes back up front here, everybody. Mole to mole step, right? Zayden, where does the mole to mole step come from?
Oh, from the grams.
Good. No, wait, from where? The mole to mole, where do we look? This is what you just asked me on the last question.
Oh, on the equation.
Good. So what would go here?
Oh.
Good. And what would go on the bottom?
2.
Let's see, 2.
Good. Have a smiley face, Zayden. Good job. Okay. And then final step, mole to gram, back to molar mass. So 1 mole of copper is,
62.55.
thanks, Caitlin, 63.55.
Wait, how would you type
So
that?
where did we go back to on the last step?
So I would type it in. Sorry, what was that, Kens?
So on the last step, we went on the top right. On the very
Uh-huh.
last one.
Right here. Yep. So I would type in 0.1, divide by 169.87, divide by 2, times 63.55 is how I would choose to type it in.
Do we have to do 0.1 or should we do 0. So it'd be 0.02, right?
Can you put like the 0 in front? Yeah, that's fine. Yeah. I just ignore all number ones when I'm doing my calculator, right? And if it's on the bottom, I divide it. If it's on the top, I multiply it. So, questions on that? Setups, numbers, where something came from? You can eat your M&Ms now. Yes. So by starting with it, it's like having it be on the top of our fraction. Because in a sense, we're just merging these all into one thing. So the is being times. Does that make sense, kind of? Yeah, so just whatever's given first, you just start with that number. So. Okay, everybody heads down real quick. Put your head on the desk. Head down real quick. Okay, on a scale of 1 to 5, show me how ready you feel to start trying the homework. 5 is I'm ready to go. 1 would be I want to do more together. Okay, hands down, heads up. Okay, last thing we'll do here, and then we'll jump into the homework, okay? Go to the very last problem in this section of your notes. Okay, just one little thing here, and then I'll let us get, by the looks of it, most of you are ready to go. I just want to do a quick little demonstration here to make sure we're remembering that these things are not just letters and numbers on a page, right, but they represent real things. Okay, so those cups are tiny. Okay. For a smiley face, don't say it out loud, but place your red and blue M&M on your map without saying anything where you're starting and where you're going in this problem.
Okay. Slide, Janie. Slide.
Okay, if you have this as your end goal and this as your starting goal, you can have a smiley face. Okay? Now, take a second here, everybody. And let's understand what this question is actually asking in real life. Okay? So there's two parts to our objective today. Notice, it's I can use a conversion map to solve stoichiometry problems. That's great. You need to be able to use the map to get an answer. But you also need to be able to understand what that answer means. Like, what is that number? What is that actually telling you? And that's going to be part of the quiz as well. It's not just being able to do the math, but I want to see that you understand the full chemistry triangle. Like, what does this number represent for us? Okay, so in this problem, can someone rephrase without just reading the question? Like, what is it we're finding in real life with this question? Boston?
You have 50 grams of water. How many liters of carbon dioxide gas is produced?
Can you say without, just reading the question, though? Like, put it into your own words.
Oh, I can.
But, what does that mean?
Oh. If you have 50 grams of water, you want to know how much carbon dioxide gas you get in the water.
Ooh, not quite. You're mixing it up a bit, but have a smiley face for trying. Anyone else willing to try here? What does this actually mean? I'll show you what I'm doing, and then this might help, okay? So looking at our balanced equation, okay, we're going to do this in real life. I have some propane gas, C3H8. Okay, that's what's in my gas line. Okay, what am I going to react the propane with?
Heat.
Oxygen.
Oxygen. Where am I going to get the oxygen from?
Air.
It's here, right? So there's a gas in here. We're going to react it with the gas, the oxygen in the air. What is it going to make after it reacts?
Carbon dioxide and water.
It's going to make carbon dioxide and water. So what is my question asking in relation to the actual, real life experiment? Zayden?
Like, from this reaction, would it be how much carbon dioxide, how many liters of carbon dioxide did you get from it?
You're getting closer. So notice here that is carbon dioxide a reactant or a product? It's a product, right? Good. How's my face for noticing that, Zayden? Jacob? Expand that. So look at this there, everybody. We're comparing carbon dioxide, which is a product. What's the other thing they've given us? Is it a product or reactant? Is water a reactant or a product? It's a product. We're comparing products and products. So this is where Boston was off just slightly, is a lot of times we think of things as okay, this is making that. But if you look at the balanced equation, the water's not making the CO2. The water and CO2 are both being made. So what it's saying is, if I do this demo and I make 50 grams of water, how much of that is also being made? So the thing with stoichiometry is it can compare product to product, it can compare reactant to reactant, or it can cross the line. But the process doesn't change, the map doesn't change, even though where you're starting and where you're going might be different. Does that make sense? Kind of how to read these and what they're saying? Okay, now I'm going to do the demo. The one downside is I'm not going to be able to I'm not going to go into the work of capturing my carbon dioxide, right? But that's in a sense what we'd be finding now is if I could capture the carbon dioxide as it reacts, right? That's what we're finding is how much of it did I make, okay? Now for demonstration purposes only, I am going to trap, so I have it hooked up, once again, propane's in here. I have water and soap, because otherwise it's a gas and we don't see anything. So I'm going to put the gas in bubbles so we can trap it, so we can see it, right? And then, just like before with our magnesium, it does need a kickstart to get going. So Kenzie, will you come help me? Kenzie's going to help me kickstart it. I've known Kenzie for multiple years, so I trust that she won't Light me on fire.
That is true.
Light me on fire. I could tell when she took off her Apple Watch. I was like, uh-oh.
Apple Watch. Oh, Jamie. I was like, I don't have an Apple Watch.
Okay, take this. Okay, so what you're gonna do is when I say go, you'll just light a match and touch it to the bubbles.
Just like drop it in there.
Like, there'll just be a tower of bubbles on my hands. And you
Yeah.
just touch the bubbles.
Okay.
Does that make sense?
Okay.
Do it from like
Drop
an
it
arm's
on
length.
fire.
Because it'll be quite hot.
I've seen people do this on like those
Got it.
videos.
Mostly for my flammable hair.
That's true.
For some reason, I don't see this
I did that one time on purpose. I don't know why. It was when I was like 7.
Why would you?
But my hair was
Okay,
wet. So
so right now the methane is inside of these bubbles. Where's our oxygen? In the air, right? Okay, Kenzie is going to be our Kickstarter to get them to react with each other. And then what is going to be created?
CO2 and water.
Right, so we're going to make carbon dioxide and water. Okay, ready, Ken? Got it.
Need help?
Okay, 3, 2, 1, activation energy.
Wow, that was actually so cool.
Right? I'll do them. Oh, it's smelly though.
It smells great.
Thanks, Kenzie. So what we saw there, all that heat was a result of the two atoms, right? The propane and the oxygen reacting. And then, of course, we can't see the products because they get turned into gases as well. But, okay? Okay, open up your homework packet to the page that says Stoichiometry number 2. And that is our assignment for tonight.